Good afternoon, student. In the previous lecture, we have studied the weathering and mass wasting. In today's lecture, we will study the next part of the second chapter, biological weathering. It is the disintegration of rocks as a result of the action by living organisms. Roots of trees and other plants can wear away rocks as they influe into the soil. The roots get bigger. They utilize pressure on rocks and makes the cracks wider and deeper. Eventually, the plants break the rocks apart. Microscopic organisms such as algae, moss, lichens, and bacteria can grow on the surface of the rocks and produce chemicals that have the potential of breaking down the outer layer of the rocks. The amount of biological activity depends upon how much is in the air. During animals can speed up the development of fishes. Anthropogenic weathering. Anthropogenic weathering. Man being a biological agent affects weathering. With economical and technological development, man has become the most powerful weathering and erosion agents. Mining, blasting of hill and range for road and dam construction, qualifying in the industries, and building material, etc. result in a fast rate of disintegration of rocks. These may be accomplished by natural weathering process in thousands to millennium of years. Man's speed increase the rates of weathering on hill slopes through active like deforestation. In the next video, we will look the biological and anthropogenic weathering. Let us see. Next, weathering process. Some rocks are more unborn. while others are less resistant to weathering process. Some rocks react in a different way to different type of weathering. For example, quartzite metamorphic rocks is harder than the even steel. It does not easily react chemically, but it is easily break by physical weathering. Under arid conditions, limestone does not easily weather away, but it does do so easily in humid region. Granite resist weathering is arid and semi-arid region, but the minerals inside it are prone to chemical weathering easily. Rocks having vertical plane are easily full and broke down due to temperature changes, forest action, weather, water and wind actions. Importance of weathering. Weathering prepare to way for formation of soil and various landforms that we see on the earth. Transport from one place to another and deposit to from landforms such as deltas, beaches, plains, etc. Weathering helps in the enchantment of focusing of metal. In region of high rainfall, the leaching process remove basis from present rocks. As a result, iron or aluminium get a concrete in upper layer, for example, literate or bauxite. Next, mass wasting. Mass movement or mass wasting is the downslope movement of loose mixture of soil, land and rocks particles by the force of gravity. In mass movements, and the material come down the slopes without the aid of the transportations, medium like running water, ice or wind. Mass movements occur contribute on all slopes. Some act very slowly, other very suddenly, often with troublesome results. Let us, let's, let us look at the factors responsible for their movement. First is a relief and slope. Such movement will not occur in plain area. Hilly, mountains and plateau area are more vulnerable to such movements. The sleeper, higher are the changes of appearance of mass movements. Gently slope will have to slow movements while steep slopes will have rapid movements. Second is a gravity. Gravity is the main force responsible for mass movements. It is a force that acts everywhere on the earth's surface, pulling everything down. Third is a water. Addition of water from rainfall or snowfall or melting of snow make the material on the slopes heavier. Water can seep into the slope and rock and increase their weight. Water can reduce the friction along sliding surface. All those factors increase the changes of materials coming down the slope. And fourth is a weak material and structures. Some rocks are weaker than others. Rocks which have joints break easily. In particular, rock containing calcium or clay minerals tend to have a low strength. Such area will be more sensitive to mass wasting. Next is a mass movement. Mass movement can be divided into four main classes. Fall or triple happen when rocks have the free fall and land at the bottom of a slope. Flows are mixture of water, rock and weathered material. They move very quickly. Large flow can bury entire village. Smaller flow can block roads. Third, a slide happens when a section of soil or rock suddenly gives way and move down a slope. The material moves as a single mass along a slippery zone. Fourth, creep is a very slow mass movement that goes on for years or even centuries. In the fraction of a rock is a stranger on gravity for a particular slope, the rock's material is likely to stay. But if gravity is stronger, movement will occur in the direction of slope. Another factor determine mass wasting is the material of the slope. Mass wasting is effective on slopes that are made up of clay and shell. The shape of composition of individual clay particles can absorb water and prevent water from pre-cooling through the ground. A layer of clay on a slope can prevent water from filtering through the slopes. Insist the water stay near the surface and structure the ground. This can cause the surface layer to lose fraction and slide. A third factor that influence mass movements is the load or weightage on the slope. Construction activities on slopes and heavy rainfall can add weightage to material on the slope. There are several other ways friction can be reduced along a slopes. For example, wildfire, removal of vegetation, or adding too much water. Types of mass wasting. First is a creep. Slowest moving down the slope movement of soil types of the hills, assure along top and basal portion of hills. Second is a rock fall. Rapid fall on rock material down a cliff face or assure mainly in rock areas. Third is a earth follow. Rapid or slow. Water structure the soils, typically assure the hillsides in humid region. Fourth is a solidification. Solidification is the name for the slow downhill creep of soil in per glacier or alpine region. It assures slowly and is measured in millimeters or centimeters per year. As a perform is impermeable of water. Soil overlaying it may become overstandard and slide slope down under the pull of gravity. Fifth is a landslide. Assure the moderately steep slopes, movement of rocks, earth, or debris down section of land as a single unit. In the next video, we will look at the mass wasting or mass movements. Let us see.
Mass wasting. The large-scale movement of loose material derived from weathering of bedrock down a slope is known as mass wasting. It is also called mass movement. The term mass wasting is coined due to two reasons. 1. The loose material is actually rock waste. And 2. The total movement down the slope on account of gravity causes the waste of rock debris in higher slopes. In mass wasting, the presence of water, wind, and glaciers are contributory factors. But the movement is basically on account of gravity. The steeper the slope, the more rapid is the movement. Various processes are involved in mass movements, such as fall, creep, slide, etc. All these processes can be divided into two categories: slow movement and rapid movement. In slow movements, gravity is the main factor. Water plays an important role, but since the movement is down the slope, presence of water may not be an important factor. Slow movements can be divided into two main types. The first type is creep. The slow downhill movement of debris is called soil creep. It may take place in the form of soil creep or rock creep. Soil creep involves fine weathered rock debris, while rock creep involves unweathered block of rock. Rock creep is not affected much by seasonal climatic conditions. It is affected more by distortions and bends in rocks, which offer resistance to gravitational pull. On the other hand, seasonal climatic conditions play an important role in soil creep. The second type of slow movement is solidification. In this type, water mixed with soil forms clay, which moves as a thick viscous fluid. It is more dominant in certain glaciated areas. In rapid movements, water is the main factor. There are four major kinds of rapid movements: landslides, earth flow, mud flow, and sheet wash. Landslides are most common, significant, and also observable. Landslide is the only exceptional rapid movement in which water is not the main factor. Landslides involve both rocks and soil. Their movement is characterized by a sharply defined shear plane. Shear plane is a surface which breaks off and on which movement takes place. Landslides take place when a support in front of a rock or mass of debris is removed by natural or artificial forces. The downslope movements occur in many ways. The first is fall, in which under the influence of gravity, rocks or their fragments fall down instantaneously from steep hill slopes. The second type of down movement is slide, in which the downward movement is along a certain path. Most landslides, however, occur rapidly. Landslides are often triggered by earthquakes, heavy rainfall, or by wind action. Earth flow is the movement of waterlogged material down a slope. Earth flow is common in areas having rich alluvium soils and on hillsides. In mud flow, water content is more than in earth flow. The debris is transported by the stream and rivers as mud. Mud flows occur in areas where vegetation is not present and slopes are steep. In arid regions with steep slopes, mud flows are common during rainfall. Sheet wash involves the rapid movement of rock debris or soils saturated with water-like viscous fluid. During soil erosion, large sheets or layers of soil are removed by agents of gradation like water, wind or glaciers. It is termed a sheet wash. On account of deforestation, the sheet wash has affected many parts of the world. Mass movements or mass waste create varied landforms such as meanders, terraces, scars, ripples, escarpments, mesas, etc. Landslides on Himalayan hill slopes have created many lakes. Because of a wide range of variation in mass movement, the topographic features also vary in size and shapes.
Thank you, students.